Okay, this is the virtual office hours. It's Sunday afternoon, about 6:34. And I received, well, to take off the repetition, I received 4 homework questions. I think 4. And they're all on 7.1. So what I'll do is I'll go ahead and go over them, and that way all the 120s can watch them. Well, I know all of them aren't, all the students, 2 or 3 out of each class will watch these videos before class, and I'll go over them in class also. So the first question we got is 7.1 13/5. 7.1 13/5. 7.1 13/5. And this is a uniform, just like we did in class. I'll draw a representation of the graph over on my white sheet. This one does give us a height of 1/30. We know that the area is 1.0000, and our base is 0 to 30. $15 in the middle, 20, 25, 5, and 10. And A says, what is the probability that the friend is between 10 and 20 minutes late? What is the probability that the friend is 10 to 20 minutes late? And then if it is 10 a.m., there is a 20% probability, 20% probability that the person will be late. So how many minutes does that count? Does that fit into? All right, so this is just like the problem we did in class. And here is the question. So A, I'm gonna put over here A, and I'm gonna take my handy dandy highlighter, and I'm going to highlight the base, 10 to 20 minutes. So 10 to 20 minutes. 10 to 20 minutes. Not hard. And what does it say? It says between. Between means what? Between, in the middle. So that means that they want this area right here. So the probability of between 10 and 20 minutes is going to be equal to base. Base is 10 times 1/30 height. And that's going to be equal to 10/30, which is equal to 0.3333. That's how you do A. Now B, they give us 20% probability. So I'm going to change that 20% into 0.2000, and that's equal to our area. So therefore, 0.2000 is equal to base times 1/30. And just like the problem we did in class, divide by 1/30. Divide by 1/30. And B is going to be equal to, and I'm going to take my handy dandy calculator, And I'm going to take, let me clear everything so we don't get mixed up with other stuff. Clear and clear. So that'd be 0.2000 divided by, parentheses, 1/30. So our friend, if we meet at 10 o'clock, he's going to be 6 minutes late. And that's our answer. So A, there's a 33% chance or 0.33 probability or 0.333 area between 10 and 20 minutes. And then if they give us a 20% chance that somebody's going to be late, that 20% means that they're going to be 6 minutes late, which if we meet at 10 o'clock, then that person should show up by 10:06, 6 minutes late. And I'll leave that on the board for a few minutes. You can hit pause and catch up wherever you need to catch up. So let's type in our answers. Round to 3 decimal places. And 6 minutes. That's a test question. Now you've got 2 or 3 in your notes, because I know I at least did one uniform question in your notes. Next question, 7.1, 15/6. 7.1, 15/6. I think that's kind of the same question, isn't it? I'm looking. Okay, no, it's not. 7.1, 15/6. You've got uniform distribution. Base is 0 to 30. So therefore the height is equal to 1/30. And the area under the curve is 1.000. And they want to know, find the probability that someone's going to be at least 20 minutes late. Okay, so we go to our handy dandy whiteboard. And we know this is 15, and this is 5, and this is 10, and this is 20, and this is 25. And we draw a line at 20. And what does at least mean? That means that 20 is the lowest number. So if 20 is the lowest number, that means everything to the right of it. So they want to know the area of orange. So we know that the area is what we're trying to find, area that at least 20 is equal to base, which is 10, times 1/30 height. And that's equal to 10 times 1/30. I just rewrote it. Which is equal to 10/30, which is equal to 0.3333. And that's your answer. So there's a 33% chance that your area will be 0.2000, or you have a 0.33 probability that the student will be at least 20 minutes late. So you got a 33% chance. 0.33. Oh, 0.333, sorry. There's round to 3 decimal places. There we go. Okay, so I'll leave that on the board there for a second. And that is how you do that problem. And let's go to the next problem. (7.1) 35/15. Now, there is 3 questions from different classes on this one. So I'm just going to do it one time. 7.1 7.1.35/15. Now you may think this is it looks like a 7.2 question, but it also looks like an empirical rule question. So I don't know. We're just going to have to see what it is. I really don't know what it looks like an empirical rule question because it says mean of 266 and a standard deviation of 16. So when you see a mean of 266 and a standard deviation of 16, that means draw the curve. And I've been telling y'all that since the 3rd chapter. Okay, so I'm going to draw the curve. Here's my curve. I'm going to have to use a calculator on this because I'm not going to try to do it in my head. There's the curve. And 266 plus 16 equals plus 16 plus 16. So the 3 on the right is equal to 282. So 266 in the middle, 282, 298, and 314. And then we're going to subtract 266 minus 16, minus 16, and minus 16. So that's going to be 250, 234, and 218. So now that I've got my curve drawn, I can go ahead and highlight these as unusual. And highlight these as unusual. And everything else y'all know is normal, which is the green, but I'm just not going to take time to do that. That's this area right here. Okay, now I don't know what they're going to ask, but the first sentence that says the mean is 266 and the standard deviation is 16, that tells you to what? Draw the curve. Now let's see what the second part of the question says. It says the figure to the right represents a normal curve with m is equal to blah, blah, blah. The area to the right of 280 is 0.9018. Okay, I don't have 280, but we can draw it somewhere. Okay, 280, and I'll do it in yellow. 280 would be right in here. So I'm going to draw a line right in here, and we're going to call that 280. And they're saying that the area to the right of 280, take my handy dandy yellow highlighter out, the area to the right of 280 including the pink area, is equal to 0.9018. what did it say? 0.019. Let's see, what did it say? 0.1908. So the area of the yellow area, according to the directions, is 0.1908. So that means the area in that yellow region is 0.1908. It also means that the probability greater than 280 is equal to 0.1908. And there is a 19% chance that your number is going to be above 280. That's, remember when I told y'all that probability and percent and area equal the same thing? Well, that's pretty much what I just said. The area in this yellow area is 0.1908. The probability that the score is going to be above 280 is equal to 0.1908 or 0.19. And then there's a 19% chance that your score is going to be above 280. So that just shows you how the three can be compared to each other, just context. It either asks for the area, it asks for the probability, or it asks for the percent. They're all three the same thing. Okay, now let's see what the question asks. The proportion of human pregnancies that last more than 200 days is 0.1908. That's what we just talked about in yellow. Okay. Provide a secondary. Okay, well, the complement of 0.1908, and we'll do it in blue. The complement of 0.1908 is the left-hand side. And that is this side right here. And if the yellow area is 0.1908, then what is the blue area? It's the complement. And no, you're never going to get rid of the complement, so you might as well just learn it. And we've been talking about the complement since chapter 3. Chapter 3. And 1 minus, because this whole area is 1. Area under the curve is 1, and if you want to, we'll just do that. 1.0000 minus 0.1908 is equal to, well, let's do it on the calculator so we can make sure everybody understands what we're doing. So I'm trying to find this blue area. So 1, the whole area under the curve is 1, minus the yellow side, which is the right side, is equal to the left side. So calculator 1 minus 0.1908. I got 0.8092. So 0.8092 is equal to this blue area from negative infinity to 280. And that's how you answer that question, that less than 280 is 0.8092. We'll leave that on there for a minute. So you can hit pause. And the probability less than 280 days is 0.8092. Okay, I don't understand. 0.809 maybe? I don't know what it's wanting. $2.80. No, I'm sorry, that's not right. Wait a minute. Okay, I'm thinking that, okay, they were just, okay, I'm sorry. They were wanting you to say greater than. Okay. I thought they were looking for the left-hand side. They're just wanting you to say this again. Okay, I don't know why they're doing that. That's kind of ridiculous and redundant. But anyway, the figure to the right represents a normal curve with 280 in 16 days. That's what we just drew. Okay. X is equal to 285 and X is equal to 305 is 0.10. Okay, so now they're saying we're going to draw another curve. And they're saying with this curve, let me find another. Can't find my curves. Hold on a minute. Let me get a curve. There we go. So I've got to copy everything onto this curve. Let me copy this right quick for you. So 266, 282, 298, 314, 250, 234, and 218. And they're saying that they have a probability, the area between 305, and we'll do this in blue, 305 and 285. 285 would be right in here. Is equal to 0.1101. So between 285 and 305, that area is 0.1101. So this area right here is 0.1101. So that means is equal to the area. That means that between 285 days and 305 days, there's an 11% chance that you might have your baby. Chance of having a baby between 285 and 305. Okay, or you can say the probability of having a baby between 285 and 305 is equal to 0.11 or 0.1101. So there again is our context of percentage, area, and probability. Depends on what the question is asking and what they are asking you to put the answer in. Okay, usually area and probability is 4 decimal points. Okay, usually those are the 4 decimal points. Percentage, you can't put in 4 decimal points because you got to move the decimal 2 places to the left and get 11% because of the 100, over 100. So the question can say there's an 11.01% chance that you're going to have your baby between 285 days and 305 days. The area between 285 days and 305 days is 0.1101, or the probability that you will have your baby between 285 days and 305 days is 0.11 or 0.1101. And that's the way that, they're going to ask. Okay, so that's what you're going to say in the next problem. Between, B, is between 285 and 305 is 0.1101. And then they're going to do a redundant. I don't know why they're doing this. Between 285 and 305 is same thing, 0.1101. And that's it. And what they're trying to get you to do is understand the drawing that you draw. That's what they're trying to get you to do. So if you're trying to do this homework without drawing a picture, then you might as well not even do it. Okay, because you're not going to understand it. Okay. So this is greater than, the yellow area, greater than. I added the blue area because I thought they were going to ask for the blue area, which is the complement. And this is between. And this is not using your calculator. This is nothing but, like I said, the empirical rule. And they're telling you the area, and you just plot it and just interpret it like I told you. A score greater than 280 or over 280 days is 19% chance, a probability of 0.1908, or the area under the yellow region is 0.1908. The area less than 280 is 0.8092, which is the complement of 1, which is the area under the whole curve, minus the yellow area, which will give you the blue area. And this, there is a 11% chance, 11.01% chance that your baby will be delivered between 285 days and 305 days. Okay? And that's number 35. And like I said, 3 people asked that question. So I'm not going to do it 3 times. And the last question is 7.25T2. Now, I don't know if we've covered this in class or not. I'll look at the problem and see. 7.2, number 5. It says T. I don't know what T means unless it's technology, /2. Now, let me see if it is a test question. I think it is. Oh, yes. There's 4 test questions here. 1, 2, 3, and 4. And I'm going to draw 4 pictures. Okay? So now they don't give you because they're assuming that the area, the mean is 0 and the standard deviation is 1, like I told you. So here is, man, I got to put lines. I don't like these I don't like these charts because they don't have a line. Kind of drives me bananas. And here also. All right, so I'm going to draw the first one, 1.65. It says equal 1. So all of these are equal. And it says determine the area that lies to the left of these numbers. So 0, 1, 2, 3, -1, -2, -3, 0, 1, 2, 3, -1, -2, -3. Now, the first problem, Z left of 1.65. Left of 0.01. And let's go ahead and draw our other ones. Get them out of the way. I'm drawing them. I'm going to show them to you in just a second. And again, I'm using these curves that don't have a line under it, so I'm having to draw a line. So just bear with me. You be drawing your pictures. You be drawing your curves also. And this is going to be left of 0.94 and left of negative 0.49. 0, 1, 2, 3, negative 1, negative 2, negative 3. Oh, I already got this. Okay. All right, so here is our four drawings. Here's the first two. And left of 1.65. Well, 1 is right here. There's 1.5. So 1.65 is going to be right about there. And that means we're going to highlight. Now, I'm going to go ahead and highlight my areas that are unusual, just like we always do. Which it really doesn't matter here, but we are going to add up what we think is empirical rule percentage. They want to know this area right here in blue, left of 1.65, sorry, it's supposed to be 1.65. It's supposed to be 65 down there. Now I'm going to take my blue pen and I'm going to add up all these by the empirical rule. By the empirical rule, 0.15 plus 2.35 plus 13.5 plus 68. And I don't know, 1.65. 1.5 would be 6.75, so I'm going to say 7. And I'm going to add those up. And 0, bring you 1, that's 5, 6, 7, 8, 9, 10, bring you 1. That's going to be 68 plus 7 is 70 what? Oh, I can't add 7's worth of flip. 75, 88, 90, 91. I got 91. So by the empirical rule, I'm going to say it's around 91% or 0.9100. Gmail. Now I'm going to go to normal. CDF. And I'm going to do from negative infinity, negative 9999, to 1.65. Negative 9999 to 1.65. So take our handy dandy calculator and do, let me clear everything so everybody's on the same sheet of music. And clear. and clear. So I'm going to do second bars, normal CDF, and I'm going to go from negative 9999 to what I say it was 1.65. And by the empirical rule, I got 0.9100. Let's see what they get. 0.9505, and that is the correct answer. 0.9505. And that is the area in blue. 0.9505. So we go back to our handy dandy question and we type in 0.9505. And that is correct. All right, so let's do the next one. So here we go. 0.01. Good gracious, that's just off of, God, that's like right next to 0.01, be right next to this line right here. Well, you know that line is at 50%, so I'm not even going to, I'm going to say it's around 51%. It's going to be less than that. So by the empirical rule, let me go ahead and draw what I need to draw. We want to know this area right here, and that black line represents 0.01. So I need to put that right here, 0.01, and this is negative 9999. But by the empirical rule, I'm going to say it's 50.5% or 0.5050. And I'm just guessing because that's so small, it's going to be very small. It's just going to be a tad over 50%. So I go to my handy dandy calculator and I hit second to save time. I hit second, enter, and I change that 1.65. I changed it to 0.01. The reason I do that is to save the place values in case I need to type in 3 digits later on. You don't have to do that. That's just what I do. Now, by the empirical rule, I got 0.5050. Let's see what they got. 0.5040. So I'm a little bit off. So equals 0.50. Actually, it is 0.5040 because that 8 knocks that 39 to a 4. So 0.5040. So let's take that over here to the question. 0.5040. All right, let's do 2 more. Left of 0.94. Well, 0.94 is going to be right in here. .94. Well, let's see. This is 50, and this is 50 plus 34% is 84%, and you're taking off 600ths. So I'm going to say it's around 0.83%. So by the empirical rule, I'm going to say it's around 0.8300 because it's right under 84%. 84 is right here on this little line right here. So we're moving it back a little bit because that's 1.94 is right there. So I moved back off of 84 a little bit. So I'm going to say 83. So we go to normal CDF from negative 9999 to 0.94. And that will be the area to the left of that black line. I say it's going to be around 0.8300 by the empirical rule. But by the calculator, second vars. Ooh, I didn't mean to do that. Second, enter. And I'm going to change that 0.01 to 0.94. And enter. 0.8264. 0.8264. And that is the area in that blue area. I said it was going to be 0.8300, and it came out to be 0.8264. So let's go check it out with our 0.8264. And that's it. And the last one, negative 0.49. Well, negative 0.49, this is negative 0.5 right here. So negative 0.49 would be right here. So that's going to be 2.5 and 11 and 13.5 is 16, and half of that's 17. So 16 plus, I won't say 15 because it's a little bit lower than 0.5. So that's going to be 31%. So I'm going to say by the empirical rule, we're talking 0.3100. But we're going to use normal CDF and go from negative 9999 to negative 0.49. So that's going to be second entry, negative 0.49. And I got 0.3100. The answer is 0.3121. 0.3121. And that's how you do those 4 test questions. Okay. Drawing a picture helps tremendously. If you try to do these problems without drawing a picture, it's going to be very difficult. Okay. And that's all the questions that were sent to me. And we'll do them over in class. And that way you can look at them before class. All right. I'm going to shut her down, and y'all have a good rest of the weekend.